Hello, let's talk a little bit about the periodic table. This is just going to be a quick introduction. We'll look at the historical development of the periodic table later in the semester, and so you'll see just a whole wealth of information that we can deduce from the periodic table. That's going to be like a geography lesson as we learn how to label different sections of the periodic table. The different chemical properties of the elements can be deduced from their location on the table. And we'll see later on how the electronic configurations and all sorts of things can be figured out from the location on the table. But it's called the periodic table because the periods, those rows which go horizontally, see the elements, see a gradual change of the chemical properties, or a periodic change of the chemical properties as you go from left to right across the table. So the first period has just hydrogen and helium in it. The second period has lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The third period has sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. The fourth period starts with potassium. The fifth period with rubidium. The sixth period with cesium. The seventh period with francium. So those are the periods that go horizontally. The groups or columns go vertically, up and down. There we have, see the elements have very similar characteristics. So the first group, say hydrogen through francium, 1A, group 2, 2A, beryllium through radon, group 3A or 3B, scandium through actinium, for example. Those are the groups. So let's look at the periodic table and come up with three major areas of the periodic table. Think of this as sort of a map. So the first thing I want to point out is the stair step that you see along sort of the upper right-hand corner, those elements that are in brown, and they sort of delineate, the brown elements are one particular type of element, and the elements above and to the right are one type, and below and to the left are another. So the metals are those elements to the left and below that stair step. Metals, you know all about them, you've been around them all your life. They're shiny, they're malleable and ductile. That means you can pound on them and flatten them out, or you can pull them into long, thin wires, and they don't shatter in doing so. They conduct heat, electricity. The copper wires bring in electricity for the lights in your room or running this computer, and the copper or aluminum cookingware that your mom has in the kitchen or that you have. One characteristic of metals is that they lose electrons in chemical reactions. They like to get a positive charge. Then there are the nonmetals, sort of the antithesis of metals. They're in the upper right-hand corner of the periodic table, above and to the right of that stair step. They're not shiny. They're not malleable or ductile. They do not conduct either electricity or heat. And nonmetals gain electrons. They get a negative charge when they become ionized. And then those elements along the stair step, those are the metalloids. They can get either positive or negative charge. And they're what we call semiconductors. Yes, your calculator uses semiconductors, these very pure silicon chips that are within them. They have very small amounts of, say, gallium, germanium, or arsenic in them that allow them to pass electrons back and forth and do the computing that we want them to do. So metals, nonmetals, metalloids, the three major regions of the periodic table. Metals gain electrons, metals lose electrons, gain a positive charge. Nonmetals gain electrons, they get a negative charge. Metalloids can go either way. So here's the periodic table once again, and let's look at the groups. And so hydrogen is in group 1 or 1A. It can act as a metal or a nonmetal. Typically as a nonmetal, but sometimes it's a metal. But in terms of electronic configuration that we'll talk about later, it's put on this first column. So group 1A, from lithium down to francium, those are referred to as the alkali metals. They get a +1 charge. The second column, group 2, if you look at going from 1 through 18, that's one numbering system that's used on periodic tables, or 2A, using Roman numerals. They get a positive 2 charge, and they're called the alkaline earth metals. Alkaline earth metals, plus 2 charge. Then we have all these elements in the middle, say from scandium to zinc, that are in the duller yellow color, and those are transition metals, that they can have a variable charge, but it's always a positive charge. They could lose 1, 2, 3, 4, 5, 7 electrons, possibly even. And so those are the transition metals. So going from column 3 through 12, or 3B through 2B. The metalloids, we've talked about boron, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. Gain or lose electrons. Next column or group I want to talk about are the chalcogens. They're group 16 or 6A. Oxygen, sulfur, selenium, tellurium, polonium. If they're going to get a charge, they'll get a minus 2 charge. They often make substances that are chalky, and that's where they got their name chalcogens from. Next column to talk about is 17 or 7A, the halogens, and you've heard about halogen headlights on your car, for example. When they get a charge, they get a minus 1 charge. So fluorine, chlorine, bromine, iodine, astatine. Those would be our halogens. Group 7A or group 17. Then the noble gases are group 18 or 8A. Helium, neon, argon, krypton, xenon, radon. They don't typically participate in chemical reactions. Once upon a time we called them the inert gases. We didn't think they participated at all in chemical reactions. But now since the 1960s, we have been able to make compounds out of them. So since they don't react readily, we call them the noble gases. Then the rare earth metals are those 2 rows going across the bottom of the periodic table, the lanthanides and the actinides. So if you look back up to element number 57, you'll see a star by lanthanum. And the element immediately to its right, 72, is hafnium. Well, these elements, cerium through lutetium, 58 through 71, all fit into that little gap between 57 and 72. And likewise, between elements 89 and 104, actinium and rutherfordium, elements 90 through 103, thorium through lawrencium, would need to go in there. When we study the electronic configuration of the elements, that'll be an important thing to keep in mind. But those elements are hard to come by in nature, 58 through 71, and the ones past uranium, from 93 on, those are all synthetic elements that we made in the lab. And so that's a little bit about the periodic table, and we'll be coming back to study it some more later on.